Alright, for number 1, you needed to solve the equation. So distribute, combine like terms on the same side. After you do that, at this step you have different choices. So if you didn't do it exactly as I did, don't erase. Remember, there's different ways to solve that. But as long as you got x equals -5, you were good. Questions on number 1? Number 2, you needed to evaluate this expression for 2 variables, so put both -7 and 2 in for m and n. Simplify this. Absolute value sign is really measuring distance, so it can't be negative. Make that positive and multiply, then also. This is positive. Oh, right here. Combine -16 and -21. Just subtract it. Why did we multiply you said, why did we multiply? Yeah. Since this 4 is outside of the absolute value signs, I'm not going to pretend like it's parentheses and distribute, but because it's right next to, they do need to multiply at the end. It's already multiplied at the end. Other questions on 1 or 2? Felt like I heard a voice but didn't hear what you said. More than 80,000. Okay. For number 3, you probably had to dig back into the way back of your memory to remember what this means. When it's asking for domain, it's looking for all of your x values of the function. So for this function, you would look at your furthest point to the left and right. In this case, because it has arrows, this keeps going up and to the left forever and ever in that direction, and this keeps going up and to the right forever and ever in that direction. So that means it's going to keep going in both directions forever towards negative and positive infinity. So your domain for this would be all real numbers. That's what really both of these things mean. This one is in set builder notation, to mean x is an element of all the real numbers, all the positives, all the negatives, all the rationals, irrationals, all of them. Or you can write it in interval notation, negative infinity to positive infinity. That is all of your real numbers. Questions on that one? Or do you still need these? On the back, for number 4, you needed to solve that equation for y. So get rid of your ax by subtracting it to the other side. After you subtract it, divide everything by b, and you're left with y equals c minus ax all over b. For number 5, you needed to distribute. So a negative times a positive and a negative times a negative would give you a negative 5x plus 45. Questions on either of those two? Before we start the notes we're going to do today, I did just want to mention that if you finished your tests last week, those grades are in. If you did not, then you have zeros in right now, just as a placeholder until you finish your tests. I'm not after school today, but I will be after school Monday, Tuesday, and Wednesday of next week, and you can come see me in the morning as well. So make sure you come get that done as soon as possible. I'll be sending out like progress reports this weekend just as a reminder. Come finish your tests. And I meant to say this earlier, but I know you guys had some Khan Academies due, Khan Academy and Delta Math due previously, with some coming up. Did we have any questions on those? I think the ones due previously were just the systems of equations by graphing, Khan Academy and Delta Math.
The systems of equation ones of Khan Academy is one specific it had like our x as a fraction.
Let me try and find the exact one you're talking about. It was the systems of equations or the number of solutions? I can look at both, but... Sorry, those two things are due today. So if you have not done them, make sure they get done by the end of today. Oh, where like it would give you two equations and it would have like the x and y as fractions. That's what you mean? Okay, let's see if I can somehow hide this. So like a question like this. So what I would suggest you do is first you would need to solve both of these, get them in slope intercept form, and graph them. When you graph them, they're going to cross at one of these points to see which one. Maybe it could be this one, could be this one, you're not sure. I would put them back in the Desmos and click on the intersection point. So actually, with Desmos, you don't even have to solve these, but I would get in the practice of solving them because you'll need to do that for the quiz and test. But if I were to just put these into Desmos, now of course I don't remember what they are. 2x plus 3y equals 6. And negative 4x plus 3y equals 12. It's going to graph those for you without you having to solve it, which is nice. And it's going to show you where they intersect. And then you can convert 2.667 into a fraction, or you can put the answer choices in and see which one matches. So I could put in 3 2/3. I don't know if I can put that in as a mixed number, but let's see. Oh, what I meant to do. We need to make this a mixed fraction. 3 and 2/3 would be 9 11/3. I can do that. And you can see the decimal. And you can see if that decimal matches that point, which this one would not. And then I can do the same thing. I can also see that because my x value is -1, it has to be one of these two. I already found that it wasn't this one, so we're going to have to see which I think is this one. So you can use Desmos as a way to help you kind of see those ones with the fractions or the decimals. Were there any others on Khan Academy or Delta Math? So last class we talked about solving systems of equations by graphing. Today we're going to talk about the second way to solve systems, and that's by substitution. So when we get back from lunch, we'll start those notes. So the first part is definition. So I'm going to have you guys go ahead and copy that down. So it says a method of solving systems of equations by substituting equations within one another. And then the steps to solve by substitution are as follows. Step 1, solve one of the equations for x or y. Substitute this expression into the other equation and solve for the variable. Step 3 is substitute your answer into the revised equation, so that could be the one you solved for or one of the originals from step 1, and then solve for the other variable. So it's a lot of solve, substitute, solve, substitute. It's on Canvas. You can just go to Canvas. Some pens stop writing, so I'll give you a little bit more time. Ada, put your mask up, please. Thank you. I'm sorry. Who is still writing? Okay. So we're going to do more than a few examples together, starting with number 1. So in step 1, it says solve for x or y. In this system of equations, both equations are already solved for y. So we can skip that step and move on to the substitute into the other. Because both of these equal y, I can either take this equation and substitute it into this y, or I can take this equation and substitute it into this y. Does not matter, because really in this example, you're going to set both equal to one another. So regardless of how you write this, when you set one into the other, they're going to end up equaling each other. That's really crooked. From there, you would solve for x. So pick whichever one you want to move. What do we want to move first? The 2x, okay? So if I move 2x over, I would need to move 1 over. So I have negative 4 equals 2x. And divide both sides by 2. So we have negative 2 equals x. Once you have one of the variables, x or y, you're going to put that back into one of the equations to find whichever one you don't have. So here we have x, we need to find y. So we're going to put negative 2 into, you can choose either equation. I'm going to show you that both work, but you just choose one. So you can put it back into the first one, 4 times negative 2 minus 1. Or you could put it back into the second one, 2 times negative 2 minus 5. Pick one of those two, you don't need to write both, and simplify that, figure out what y is. No matter which one you chose, you should have gotten negative 9. Now that we have our x and our y value, we're going to write those as an ordered pair. Negative 2, negative 9. That would be our solution to this system. They would intersect at one point. Do you have any questions on that process, how we got that answer? We're going to do number 2 next. For number 2, there's one equation that has a y equals and one equation that is not in slope-intercept form. We don't have to worry about solving that one, like putting it in slope-intercept form. We're going to take the one that says y equals. We're going to substitute this equation into the other one where y is. So it's kind of like when we're evaluating, we're putting numbers in for variables and solving or simplifying. We're doing the same thing, but now we're taking whole equations. So I'm going to rewrite this bottom one, 2x plus 3, but instead of putting y, I'm going to put what y equals, which is that equation 6x. After we substitute that equation in, we can start solving for x. In this case, we would need to combine like terms on the same side, so add these two together to get 20. and then divide both sides by 20. And then we're going to put what we found for x back in for y. You can really put it back into either of these equations, but the one that solved for y would be easier to do because it's already solved for y. So this would give us -6. And then we have our ordered pair, -1, -6. Do we have any questions on that process, how we got that answer, anything about that? Ralph, did you have a question? Yeah. Okay. Once you get the hang of this, the process is really the same. It's just tedious work, really. So let's do number 3. Same thing. This one has a y equals, so we're going to take that equation, put it into the other one where y is. If it helps to kind of put parentheses or like circle what the equation is, so you know this is the piece I'm taking and putting it in the equation, you can do that. It's not necessary. And then rewrite the second equation, 3x plus 8, but instead of y, put x plus 9. And then once that equation is inside the other one, you're going to solve for x. So anytime you substitute an equation into the other, one of the variables disappears, and that's what you want. That way it's easier to solve. So we would combine the terms, get 11x. Get rid of the 72 by subtracting. And then get x by itself by dividing both sides by 11. So x equals -7. And then put that back into your y equation. Again, you can do either of these. This one, the second equation, is a little bit more work if you put that back in there. But you still can do it that way. But this one would be easier if you put this in here because it's already solved for y. So your ordered pair or your solution would be -7, +2. For number 4, it's a little different because we have an x equals equation. We're still going to do basically the same thing. We don't need this to be a y equals, it just has to be x or y. But since this is an x, I'm going to take this equation and put it in for x in the other equation, not y. So when I rewrite this, this would be 2 times 4y plus 7 minus 6y equals 12. So I'm going to end up solving for y and not x first, which is fine. So distribute and get y by itself. combine my terms, subtract 14 to the other side, and divide both sides by 2. Once you have your y value, you can put that back in for your x equation. Again, you can do either or, but this one would be easier because it's already solved for x. And you would figure out what x is. And 4 plus 7, so x equals positive 3.
When you do the second part, you don't add like the other part of the equation to try to get x.
Like this part? Yeah. Once you have this, you're just putting it back into one of the equations. It doesn't matter which one, but you're not like doing this process again. Or
Coordinates would be 3, -1, right?
yes. So be careful with problems like this because we solve for y first, but in your order period that still has to go second. So if you do all the work right, but then put the answer wrong, that would not be a solution. -1, 3 would not be a solution. Do we have any questions on this so far? We're going to do 3 more examples together, then I'll let you practice them. Anyone still need number 4 before we go to the next page? We're going to do number 5. In number 5, we don't have an equation that's solved for x or for y. So we're going to have to solve for one. In these type of problems, look for a variable that's like by itself. It doesn't have a coefficient or its coefficient is 1. That would be the variable you would want to solve for. Now, that does not mean you can't solve for the x with the 2, the x with the 5, or the y with the 3. You can. But what's going to happen is you're going to end up with equations that have fractions, which is fine, but you'll have to be very careful when doing this process. But if you avoid all that and just find the one that has a coefficient of 1 or -1, that would make your life easier. So I'm going to take this equation and I'm going to solve for y by subtracting x to the other side. Or 2x, sorry. Now, normally when we do this, we get it in slope-intercept form, so we switch the x and the y. In this case, since we're substituting it, that part doesn't really matter. You can put -2 minus 2x, or you can put -2x minus 2, either or. That order does not matter. Once you have that equation, you can put it back into the other one. I'm going to take -2x minus 2 and put it back into the other equation where y is. So this would start off 5x plus 3, and then times the equation we just found. -2x minus 2 equals -8. And then we're going to solve from there. Solve for x, figure out what that is, and then find y. So this would become 5x minus 6x minus 6 we can combine these like terms, get negative x minus 6, get rid of the 6 by adding, and then divide both sides by negative 1. After all of that, we still have to go back and find our y value. So now you have 3 different choices you can use. You can put your x value into one of the original 2 and solve, or you can put it back into the one you solved. Either or, this would be the easiest of the 3, but all of them will give you the same answer as long as you do that math correctly. So this would give me y equals negative 2 times positive 2 minus 2. So negative 6. So our ordered pair would be 2, negative 6. So with problems like that, there's a bit more work you have to do. But once you get an x or a y equals equation, the process is really the same. Yes, Shikai.
So we have to break it down and solve it to get it to how you did.
Yes. So anytime it's in standard form, look for an x or a y that's by itself, solve for that variable. And then the rest of the process is the same. Any other questions on that one before we do, we're going to jump to 7. Okay, so for number 7, same thing. We don't have an x or a y, so we need to solve for one. This x right here, try that again, has a coefficient of 1, so that's the x I'm going to solve for. That doesn't mean you have to solve for that x, but it would make your life easier if you did. So to solve for this x or get x by itself, we would need to get rid of 5y by subtracting it to the other side. I'm just going to leave this in the same order, 4 minus 5y, which is fine. If you switch it and put negative 5y plus 4, that's also fine. And then we're going to take this equation and put it back into the other equation where x is. So that's going to be 3 times 4 minus 5y plus 15y equals negative 1. From there, we're going to solve for y. So this would become 12 minus 15y plus 15y equals negative 1. When we combine our like terms, the negative and the positive 15s cancel, become 0. So our y's disappear and we're just left with this. What type of solution is this? Not infinite. Does 12 equal negative 1? So what type of solution would this be? No solution. So when you're solving this by substitution and you are doing the process, but your variable terms cancel, and you're left with two numbers that don't equal, that would be the same thing as if we were just like solving equations. You get two numbers that don't equal, it's not a solution. If we were graphing and we got no solution, which type of lines would we have? Intersecting, parallel, or the same? Intersecting would give you one solution. Which one would give you no solution?
The same?
The same line would be infinitely many. Want to say that again? Or should I say that again? Sorry. Parallel lines would be no solution. They would never touch. They're never intersecting. That would be your no solution. So that would be the end of that. There's nothing else for you to do. Do we have questions on 7 before we go to 9? Okay, so let's start with that one. For number 9, same process. Here we have this y that is by itself or has a coefficient of 1, so that's the one we're going to solve for. So subtract 2x to the other side. You can put 18 minus 2x or negative 2x plus 18, either or. I just am in the habit of putting the x term first. And then we're going to put this one back into the other equation where y is. So that would be 6x plus 3 times negative 2x plus 18 equals 54. And then solve for x. We have 6x minus 6x plus 54 equals 54. The positive and negative 6x's cancel, become 0. And we're left with 54 equals 54. What type of solution would that be? Infinitely many. Which types of lines would that be? Intersecting, parallel, or the same? You can say it.
Oh,
The same. Because they're intersecting at every single point along both lines. So they would be the same line. So if you solve and the variables cancel and you end up with the same number just like you would in a regular equation, the numbers are the same, you get infinitely many. Do we have any questions on how to solve systems by substitution? Okay. So for the remainder of class, you have a couple different options. There are the last 1, 2, 3, 4 problems on this page you can go through and practice. You have the back page of practice you can go through. You have one Khan Academy that is due. I can't really read my handwriting on this board. I can't tell if that's today or next week. You guys, it's next week. So you can work on that. You have one Delta Math that is due the 9th, which is Tuesday. So you have a bunch of different things you could be working on. Just make sure you're working on something math related. Anyone have any questions on what we're doing for the rest of class? If you have any questions on anything, we'll be walking around. But you have this time to work. Hold on one second.